In example 91, we're looking at the graphs of two functions, one of which is one-to-one or injective and the other is not. Now we're being told that the one on the left is one-to-one and the one on the right is not. And the way that we can tell is because if you look at the graph on the left, for any particular y value that we might choose, these are our output values, there's only going to be one x value that maps to it. For example, if we pick this y value right here, this only gets mapped to by this x value right there. On the graph on the right, we can see an instance. In fact, there's many to choose from, but the graph sort of highlights this one. If you pick this y value right here, then there are two x values that will map to this particular y value. So here we have an example where we have f of -5, right? The output that we get when we plug in -5 is equal to the output that we get when we plug in 5, but clearly these two inputs are not the same. And that's basically what clinches it for us. Whenever there's a function, if you can pick two different numbers, two different inputs that map to the same output, then that function is not one-to-one. If every input maps to a different output, like we see happening here on the left, then that function is one-to-one or injective.